U.S. export controls cut off Tencent from the global supply of top-tier AI hardware, specifically NVIDIA's A100 and H100 processors. Without access to unlimited compute, training massive, dense neural networks became a physical impossibility. Tencent pivoted to engineering hyper-efficient software architectures to navigate the hardware deficit. Evaluating this ecosystem requires looking across three layers: the hardware, the benchmarks, and the cloud economics. The bottom layer reveals how they engineer around physical limits using sparse architectures. The middle layer identifies the delta between academic PR claims and real-world human preference. The top layer calculates the actual unit margins of their B2B strategy. Anticipating the embargo, Tencent CEO Ma Huateng proactively stockpiled a massive reserve of NVIDIA GPUs. This inventory creates a temporary buffer for their architectural pivot. Tencent is testing whether architectural efficiency and B2B lock-in can offset a permanent compute deficit. Training and deploying a dense model with over 400 billion parameters requires thousands of top-tier GPUs running concurrently for months. Under current sanctions, that compute cost is economically and physically unviable for Tencent. This illustrates Tencent's workaround. Left, a monolithic dense network activating every parameter. Right, Hunyuan launches sparse mixture of experts architecture. It partitions 389 billion parameters into 16 specialized nodes. The router selects just one specialist and one shared expert per query. Tencent achieves 400 billion parameter capacity, paying the compute cost of only 52 billion. To support an expansive 256,000 token context window without exhausting GPU memory, Tencent applies key-value cache compression, shrinking the memory footprint of long documents during processing. However, this sparse design introduces a technical risk known as path dependence. If a small subset of experts dominates the routing, or if a critical expert fails during a specific task, the model's logic breaks down. While the mixture of expert structure bypasses the hardware embargo, it introduces software fragility that threatens the model's reliability in production environments. Parameter capacity is only half the equation. For enterprise applications, real-time inference latency is a strict bottleneck. To accelerate response times, Tencent developed models like Hunyuan Turbo S using a hybrid transformer Mamba architecture. Look at this timeline comparison. The top line shows a standard transformer's attention mechanism, where computational load scales quadratically as the text gets longer. The bottom line illustrates the Mamba architecture, a state space model that processes sequences in a linear flow. By fusing these two methods, Tencent reports a 44% reduction in first-word delay and doubles the overall generation speed compared to their previous iterations. Hybrid architectures solve the latency problem, but mixing traditional attention layers with state space components compounds the complexity of debugging the model when rare reasoning errors occur. With these architectures established, we must evaluate how their actual capabilities measure up against both U.S. frontier models and domestic Chinese competitors. This chart maps Tencent's reported academic scores. On the benchmark known as MMLU, Hunyuan Large scores an 88.4, and it posts high marks on the math benchmark, ostensibly edging out OpenAI's GPT-4. Yet a paradox emerges in production. On the large-scale LMSIS chatbot arena, a blind crowdsourced testing ground, Tencent's reasoning model, Hunyuan T1, ranks outside the top 100. This exposes a structural flaw in AI evaluation. Static academic benchmarks are saturated and often contaminated by training data. The arena measures how a model handles messy, open-ended prompts based on actual human preference. To quantify this capability gap, we use the standard ELO logistic form equation. Comparing the top U.S. model score of 1504 against Tencent's 1387 yields a 117-point rating delta. Running the math implies a 66% expected win rate for U.S. frontier models over Tencent's best system. The technical divide between Chinese and U.S. labs now centers on post-training interaction quality and systems robustness rather than base academic scores. High performance only matters if it can be sustained commercially. We need to examine the unit economics to see how Tencent intends to monetize these models. This calculation breaks down Tencent's public API token pricing for the Hunyuan 2.0 instruct model. Processing 1 million input tokens and generating 250,000 output tokens yields an average revenue of roughly 4.13 Chinese yuan. That equates to less than 60 US cents. When weighed against the massive electricity and hardware depreciation costs of running an AI data center, this pricing structure creates an unsustainable low-margin race to the bottom. Tencent also faces a retention threat. They offer an OpenAI-compatible API interface. This lowers the friction for adoption, but it reduces a customer's switching cost to zero. A client can swap Tencent for a competitor by changing a single line of code. This scale comparison illustrates Tencent's deficit in developer mindshare. While Alibaba's Qwen open-source ecosystem commands over 17 million downloads on Hugging Face, Tencent's Hunyuan repository sits at roughly 1,600 stars on GitHub. Tencent's user licensing compounds this problem. By banning commercial use in the European Union and the UK, they suppress global developer contributions and throttle the compounding effects of an open-source ecosystem. Selling intelligence by the raw token is economically unviable. Without a secondary lock-in mechanism, Tencent cannot extract durable revenue from the B2B market. Tencent recognized this margin trap. Their actual commercial strategy abandons the API price war entirely, instead shifting enterprises higher up the software stack into their Agent Development Platform, or ADP. Inside ADP, clients embed their proprietary data into retrieval-augmented generation pipelines and orchestrate multi-agent workflows. This replaces API volatility with high operational switching costs. Moving away from Tencent now requires rebuilding an entire corporate knowledge base. Accordingly, their billing model shifts from variable token consumption to fixed software-as-a-service tiers, including enterprise subscriptions at $2,500 per month and dedicated concurrency modules. This platform approach is gaining verifiable traction. Over 150 companies, including Unity and Bamboo Lab, have directly integrated the Hunyuan 3D model into their corporate production workflows. Returning to the audit of Tencent's AI ecosystem, the results show a clear pivot in strategy. At the architectural level, sparse mixture of experts models bypass hardware embargoes, though significant gaps remain in human preference evaluation. At the commercial level, durable cloud revenue relies entirely on SaaS lock-in, not the highly commoditized token market. Tencent's broader strategy aims for deep structural lock-in, integrating AI directly into the absolute core of global enterprise workflows.